Hello, dear Laddus. How are you all? So, who already joined the class? Let me check. So, we have Sadhu, Manoj. Okay. Hi. Hello. How are you? How are you? Okay, I can see one of the comment that was quite easy. Yeah, 10th is easy. Agree. As compared to 9th, it seems quite easy. Yes. So I'm waiting for the people to join more so that we can start and let me unbox what we have today. Yes, yes, yes. So the very first thing, very good evening, Nitya. Hi. Yes. See what happens. First of all, when you are going to complete your class 9th, your examinations been over already. Maybe few of the schools have already announced their results. When you are moving to class 10th, and everyone is going to put some pressure or maybe some instructions with you that you have to score good in the board examination. From where you need to start, from how which book you need to prepare, or from where you are going to prepare yourself, and in what manner you are going to complete. Don't worry, we are here. We are going to help you out so that it would be a smooth transition for you to move from class 9th to class 10th. And this bridge course is going to help you out and will give you a comfort zone where you would be able to see, like, okay, this is quite easy. This is becoming quite easy for you to transit from class 9 to 10th, and you will also come to realize the topics are actually relevant to class 9th or maybe from class 8th. So it would be a very easy journey for you. And this is what we are over here, and this is what we are going to discuss. I welcome you all to my class, and I am going to start right now. And please be careful, those who are already in the session, you can take out your books, copy, listen to whatever I am saying, and if possible, just note it down. It would be very helpful. Although you will be getting notes, but still something has to be there in your copy. First of all, the thing is, what is bridge course? So bridge course is actually, so if you know what bridge is, so bridge is actually giving you from point A to point B. This is giving you a path to move from point A to point B, which means when you are traveling from class 9 to 10th, when you are moving from class 9 to 10th, it should be easy for you. You do not have to swim across the canal. What you have to do, you have to pass from point A to point B so that your journey is going to be easy. So in that case, it will be helping you out. This bridge course will be giving you a certain idea. This will be giving you certain knowledge about the topics, which will be helping you out to move from class 9 to class 10th. And it is also giving you a early start. So it will be a win-win situation for you. So we are with you, and I am Vikas Agrawal, your Laddu sir, right in front of you. Will be starting with the very first topic. In class 10th, we are having overall 4 chapters. Let me discuss it with, because it's a requirement. So we are having 4 chapters. The one is light. You have already came across in class 8th with this chapter. So we are having Nitya, Vedansh. Welcome to the session, dear. Welcome to the session. So very first chapter, that is light. Related to that, we are having another chapter, human eye and the colorful world. The complete name is human eye and the colorful world. Similarly, over here, light, that is reflection and refraction. Third, that is we are having magnetic effect of current, and last we are having electricity. These are the 4 major chapters that we are going to study in physics in class 10th. Question is, what is the maximum weightage? What will be the maximum weightage where I need to put more attention? So in that case, these are the 2 major topics that you need to prepare, because the maximum number of marks would be appearing from these 2 chapters, right? And these are having almost equal weightage but comparatively lesser than light and electricity. So this will be helping you out. So what I am going to do, I will be starting with light chapter, and you will be getting an idea how this is going to help you out. Can you please tell me, like, how many of you, those who are watching right now, are going to prepare for JEE or NEET, or maybe opting for PCM or PCB? Please write down in the comment box. Please write down in the comment box PCM or PCB. Whoever is going to be a part of after 10th, who have already decided, sir, I'm going to take PCM, or the one who is already ready for the opting for PCB. You can write down in the comment box so that I'll give you an idea how this is going to help you out for this PCM and PCB both. Yes, write it down. Write it down. Good, Vedansh. Fine. So how this chapter is going to help you out? Let me give you a certain glimpse about this thing. In class 8th, you started with the light chapter. Remember? Chemical effect of electric current. This chapter was already there in class 8th. And now, with the same fundamentals, you are going to study in class 10th. And in class 12th, again, you will be having the higher version, that is called ray optics. So this chapter would be highly important for you. Similarly, electricity. This is going to help you out in class 12th, again, current, electricity. So they are relevant. So this is going to help you out. Okay, Asta, PCB, Vedansh PCBs, Nitesh is PCM. So this will be helping you out. So those who are having that perception whether this is going to be helpful for you or not, this is going to be helpful for sure. Short, I'm going to give you certain, during the lectures, maybe in this bridge course, and also in the live lectures, which is going to be happening very soon. Even over there, I will be giving you the higher version of that, so that you will be very relaxed while preparing. So don't worry, I'm already there. For your information, I'm carrying a good amount of experience for you. So my experience will be transmitting towards you. The knowledge what I'm going to give you definitely going to help you out even in the board examination and maybe later. So let's start. Are you ready? Yes. Let's begin. So what topics that we are going to cover today? That is object and image. Like, what is that? Then reflection of light, laws of reflection, reflection through plane mirror. Those who are already, making their mindsets at these topics, we are already familiar with. We already know these topics. So what to do? Should I stay in the session? I'm telling you, you must be in the session, because maybe you have not studied that part which was already So you would be getting certain extra. That is my promise. So please, whatever I'm going to tell you in the next 1 hour will be helping you out. So one of the student is Vedansh is saying, I have already Rakshak sir, my dear brother. Okay. Poonam Sanger says, please take my name Vansh. Okay, fine. You are having that fantasy. I know that. Okay, let's go. So we are going to cover all these topics from the very starting, and the very first question that comes to our mind, what is light? What is light? Let me do one thing. Let me turn off the light, the complete light which is already present in the studio. What is going to be happen? You won't be able to see anything. You won't be able to see anything. Even during the night when you turned off the light of your room, what you feel, you are unable to see anything. You are unable to see anything. And this is what happens in the dark. This is what happens, right? This is what happens. How to overcome with that? You only need to turn on the light. You can light a candle, you can light a diya, you can turn on the light, because this is one of the form of energy which is actually giving you the sensation of vision. So this is the kind of definition. So the question, the very first question that comes to our mind, that is, can you see anything in the complete darkness? Answer is yes or no. Can we see anything in the complete darkness? Answer would be no. No, we cannot see. Right? Second, why do we see objects only when the light falls on them? So if you see this image, you would be getting a certain idea. This boy is having a torch and the light is striking on the mirror, and he is somewhere able to see his image, right? Which means, in case of why do we see objects? Because one of the phenomena of light, that is called reflection of light. So that is one of the reason we are able to see. Yes, yes, because of the presence of light. Let me tell you one funny incident. I asked like 2-3 years back, I asked one of the student why we are able to see, and the answer was, because sir, we are having eyes. So that was the funniest answer I have heard, because sir, because we are having eyes and we are able to see. So I suggested him to go in the dark room so that he would be able to see. Maybe his eyes are going to work in that case, but it did not happen. In the darkness, you are unable to see. The only reason the light is actually required, along with the this body part eye. So eyes are of course necessary. This is something which is actually sensing light, but light is one of the primary thing that is required for the vision. Talking about definition, yes, we have got definitely very good answers over here, that like it reflects back, it is a form of energy, we are having photons. Yes, we are going to discuss even about the nature of the light, so don't worry, I'm going to cover almost everything about the light. Yes, right. Now what is light? So we have already discussed light is a form of energy. Light is a form of, just mark this word, form of energy. It is one of the form of energy. Recently I went to one of the place, definitely like you would be able to see one of the video I have recorded over there, that will be published soon. So I went over there and I have seen the renewable source of energy, that is called wind energy. And I went to the windmill nearby to that, and there are so many forms of energy. There was a chapter even previously, like few years back, you were having one chapter in class 10 that was sources of energy. That chapter being omitted, then in that chapter you could have come across with the n number of energies: tidal energy, hydro energy, thermal energy, wind energy, certain others, ocean thermal energy. So various energies were discussed over there, and they expressed how we can produce electricity through them. So that was the past. So we are talking about over here, it is a form of energy, so that we are able to see object, just like this boy, right? Right. Energy can be transmitted. See, it's a very famous saying that energy can neither be created nor be destroyed. It can be transferred from one form to another. So if you are using a cell or a battery in a torch, then definitely that energy will be converted into light energy. It's a very easy thing to understand. So it was having chemical energy, so chemicals were there, chemical converted into the light energy. This is what happens, right? Even in class 9th, you come across with the potential kinetic energy. If you are going to drop a ball, the potential energy is going to reduce, kinetic energy convert, conservation of mechanical energy. I hope you remember all this. It's not that way long back. So again, it is a type of electromagnetic radiation. Actually, what happens when the light is falling, when it travels, it is traveling in the form of wave. It is traveling in the form of wave. It says, we say that it is a electromagnetic radiation. It travels in the form of waves, yes, of course. So these are the kind of waves. Generally when we discuss about a wave, it will be traveling like that. But when it come across, what will be the nature of the light? What will be the nature of the light? Because when scientists who are actually discussing in the past, one of the scientists expressed that it is having a particle nature, because we can see the reflection and refraction. Without that, it is not possible. It is having a particle nature. Whereas the other scientists come across with the another theory, that light is having a wave nature. So they were actually started discussing or debating with each other, like I'm the person who is right. And later they come up with a compromise, and they agreed on one thing, that while traveling, the light will be in the form of wave nature. When it is striking on the surface, it will be a particle nature. So it gives you a duality. It gives you a duality nature. The dual nature will be given to you. So remember that. Remember that. So in the form of pack of energy, photons, which I could see in the comment box. So it is traveling in the form of wave, and those photons are traveling in medium. Question is how fast the light is, how fast it can be, it can travel, how fast it can travel. So speed of light in vacuum, and that is the the highest observable speed so far. That is the highest observable speed, because in different medium we found that the speed of light is going to decrease, because if the place is crowded, you won't be able to cycle very fast. So speed is going to be slow. Light is going to have the same problem. If the medium is denser, the particles are coming closer to each other, the light is going to face difficulty. The light is going to face difficulty to travel. As a result, the speed is going to decrease. This is what happens when you do cycling in your colony. When you find the empty road, no people, fast again. When you see that there are people around, then you slow down. If you are not doing so, you are on a wrong path. So exactly the same thing is going to be happen over there. In vacuum, there is no medium. So the maximum amount of, or the maximum speed that we can see over here, that is the speed of light in vacuum, that is 3 times 10 to the power 8 meter per second. While solving even numerical, I'm giving you certain good thing. While solving numerical, what do we say? The speed of light in air, that is also 3 times 10 to the power 8 meter per second. And I asked my teacher when I was in 10th, I guess. So I asked my teacher, like, how is it possible? How is even this possible that the speed of light in vacuum and the speed of light in air is going to, they are equal to each other? How is this possible? So the answer is, the speed of light is going to decrease with a very small fraction. 29999, something like that, which is approximately equal to 3 times 10 to the power 8. So we consider that. We are considering the speed of light in air is approximately 3 times 10 to the power 8 to get a certain idea, that the speed of light is nearly the speed of light in vacuum. So we only consider that. Exactly, it is not like that. Welcome to the class, those who have joined just now. So it is the fastest known speed in the universe. Fastest known speed. So that is the reason when the sun rises, it takes a bit of time, and definitely that light is going to be incidenting on that part of the earth where the sun is going to rise. From where you can see the sunrise, the light is going to be incident over here. The speed of light is very, very, very fast. Light from the sun, that takes about nearly 8 minutes. Generally, people say it's 7.5 minutes. Yeah, it's nearly 8 minutes. Round off. Approximately, this is how you say that. Sir, approximately this is the answer. So I'm also mentioning that approximately 8 minutes it is going to take to travel from sun to earth. So the speed is, now you can imagine how far the sun is from the earth. So this is how it is. How we see moon, how we are able to see moon, because moon does not have its own light. Moon does not have its own light. See, there are two kinds of object that we discussed, or we are going to discuss, that is luminous and non-luminous. Moon does not have its own light. As you know, sun is having their own light, stars are having their own light, this tube light is having its own light, bulb is having its own light, this focus light is this, these are having their own light, whereas moon does not have its own light. How is this even possible to see moon? So the reason is the light which is coming from the sun striking on the moon surface, and whatever surface you are going to see from here. So beautiful girl standing on the horizon and watching this moon, and this portion is visible to this girl, and this amount or this part of the moon will be visible to the girl or to you also, right? So this is how it is. We are able to see because of the reflection of light, because of the one phenomena that is called reflection of light. Reflection of light. Please mark my words what I am saying right now, because the light is incidenting. It's not even that possible that you are able to see like anywhere the light is going to incident. What is actually happening, the light which is striking, that is also coming towards you after reflection, and that is the reason you are able to see. It is just like you are able to see the wall of your room. The reason is the light is falling on the wall and it is coming back towards your eye and you are able to see. Correct? The same way the moon is visible to you. Nature of the light. So as we already discussed about that, the light is having dual nature. When it comes to the wave nature, we see the phenomena of reflection and refraction. When it comes to the particle nature, it is a photon. It's a photon like particle. It is traveling in that way. So this is why it is having dual nature. It is having dual nature. Got it? Got it? Light travels in a straight line. See, if in case if I'm going to put a paper over here, if I'm going to place a paper over here, the light is not going to pass from this portion to that portion. But if I'm going to remove, again it is going to strike on the surface. And definitely you must have done that. You must have done that. You know, when you turn on the torch and you all of a sudden you just stop it and you try to see the image, the round image over your hand, right? You must have all done this thing. Exactly. The reason is because it is traveling in a straight line. The light does not travel zigzag unless it is reflected ray. Unless it is a reflected ray. So light is going to travel in a straight line always and always, right? Talking about some terminologies. Talking about some terminologies. When we talk about some terminologies, so let's look at this diagram. We are having this incident ray. Incident ray is something, the light ray which is coming towards plane mirror. Now we are talking about, we are discussing about plane mirror. Okay, before starting that, let me ask you a simple question. What is a plane mirror and how it can be formed? And or yes, yes, that is the question. What is a plane mirror and how it can be formed? Anyone, anyone. The one who joined from Poonam Sanger ID, what is refraction? That we are going to discuss possibly in the next class, because that is the second portion of this chapter. So you need to wait for that, dear. Right? Yes. What is a plane mirror? What is a plane mirror? So anyone, 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 anyone. Okay, okay. Let me just see. Smooth surface. Okay, we have got one answer. Smooth surface. Any other laddu in the class who can give this answer? What is a plane mirror and how it can be? One side is polished. Okay. Combining two mirror. Mm-hmm. Flat, smooth, reflecting surface, smooth surface that reflects back light. So yes. So almost you have achieved 90% except that combining two mirror thing. Okay, one side is polished. How can you say that combining two mirror? And also writing LOL. Highly polished. Okay, okay, fine. So great answers. Great answers, great effort. Let me tell you one thing. For example, I'm having a glass, transparent glass I'm talking about. Transparent glass from where the light is going to incident and travels back. So there are two sides, transparent, transparent glass we are having. Let's take one of the side. Let's take one of the side and the layering of silver oxide will be done. What layer will be done? Silver oxide. Silver oxide layer. Layer of silver oxide will be done on one of the surface and it will be covered with red oxide. Reason? Because when it is going to be dried, it is going to be in the powder form. It is going to fall back. Then again it will be passing the light from one side to another. So that side you have already polished. Yes, you have polished it. You have polished it. You have covered it to prevent that silver coating or aluminum coating. Right? You have already covered that silver coating or aluminum coating, and now you can see one of the side was shiny, which was covered with the red oxide, and this side will be used for the reflection purpose. Very simple. This side will be used for the reflection purpose. Yes, the surface is smooth. That will be considerable. The surface will be smooth. So we have got few answers. It is made by coating one side of the glass sheet with the okay. Of course, with us this can be done. I have already mentioned that. Silver, aluminum, these layers can be used. Of course, depending on the quality of the mirror. So when you get the cheaper one, definitely the layering of aluminum will be done. When you go to some good places, the good quality mirror, when you see, definitely silver oxide layering will be done, and this is why that mirror will be costly in the market. Yes, of course. Now, incident ray, the light ray which is incidenting on the plane mirror, we know that the light which is incidenting on the plane mirror may be coming from the actual source of light, or maybe reflecting back. When it strikes on the plane mirror, after striking, it will be reflecting back, and that reflected ray will be considered as reflected ray. After reflection or after striking on the plane mirror, the bounced back light will be considered as reflected ray. Fine. Now we have normal. Normal in maths and physics. In both, not in the real life. Sir, you are not normal. I'm not talking about that thing. I'm not talking about that thing. I'm talking about normal, which is used in mathematics and physics both. Normal means 90-degree, perpendicular to the surface or perpendicular to that point. Perpendicular to that surface or perpendicular to that point. That is called normal. So when we are having this surface, we can draw this normal exactly 90-degree with the plane mirror. As simple as that. As simple as that. And the point of incidence. So where the light incident ray and the normal and this reflected ray is going to toccaying each other or going to meet each other, that is called the point of incidence. As simple as that. So these are the 3-4 points that we need to remember, because definitions will be definitely, they ask in the examination most of the time in one marker, or maybe in MCQ they will give you a definition. You need to mark the correct option out of that. So this is how it is. So incident ray, the light which is coming from the source, bounced back light from the plane mirror, that is called reflected ray. Perpendicular to the surface, that is called normal. Incident ray, reflected ray, and normal, which is meeting at that particular point, that is called point of incidence. Done. Moving ahead. There are two laws of reflection. We are talking about the laws of reflection. I could see one of the student wrote already, Vedansh, that angle I is equal to angle R. Let me take one of the example with you. Let me just discuss. When we are going with your parents, when you are going with your parents, maybe in your car or scooter, not truck, not truck. Don't write truck or bus right now. Okay, fine. Yeah. So when you are going along with your parents and you see there's a red light, what is going to be happen? A sensible brain says you have to stop, because it's a traffic rule, right? It's a traffic rule. If you are going to break it, then definitely you need to penalize. The cop is going to catch you and you will be penalized. Correct. That is happening in your city. Maybe you are living in Jaipur, maybe you are from Chennai, maybe you are from Mumbai, maybe you are from Delhi. But this is also going to happen in Chandigarh. This is also going to happen in West Bengal, Kolkata. This is also going to happen in Manipur. The reason is it was a law that is applicable everywhere. So these are the laws of reflection, which means this is going to applicable everywhere, which says angle I will be equals to angle R. That is, angle of incidence is equal to angle of reflection. But before that, we need to understand what is angle I and angle R. So the angle between incident ray and normal, that is angle I. Angle between reflected ray and normal, that is angle R. And according to this definition, it says angle I will be equals to angle R. As simple as that. Correct? Second law. It says incident ray, reflected ray, normal all lie on the same plane. And what is the plane over here? That is plane mirror. They're talking about plane mirror right now. According to this diagram, they are talking about plane mirror. So incident ray, reflected ray, normal all lie on the same plane at the point of incidence. These are the two laws. Most of the students are getting confused. Sir, what if the surface is going to be rough? What if the surface is going to be curved? Let me give you an example about that. For example, you are having this kind of surface. Just listen to this very, very carefully. And the ray of light is striking over here. Maybe it is going to reflect like that. Maybe it is going to reflect like that because of the nature of the surface. The surface is ubad khabad right now. The surface is having gadda type of, correct? You can see that. So generally students are coming with this excuse, sir, because the surface is not smooth, the angle I is not going to be equal to angle R. This is impossible. But we have already come across with the law of reflection, that is angle I will be equal to angle R. How? How? Let me tell you. If the surface is flat or smooth, this will be the kind of normal you will be getting. What if the surface is tilted? So over here, if I'm going to draw 90-degree at this particular point, I would be able to see the normal like that. Now you imagine what will be the angle of incidence. What will be the angle of incidence? Sir, this will be the angle of incidence, and this will be the angle of reflection, which clearly states or clearly defines that angle I is equal to angle R. So it is applicable not only for the smooth surface, it is also applicable for irregular surface. Correct? 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 Fine. Let me give you one more example. The interesting one. Maybe you are having a curved surface. I'm taking an example of a spherical mirror, that is a concave mirror. Fine. Fine. Now the light is going to strike over here. Now the light is going to strike at this place. What is going to be happen? What is going to be happen? It is going to reflect back for sure. So it is reflecting back. And at this place, the most of the students are saying, no, 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 sir. Here, angle of incidence cannot be equal to angle R. That is impossible. Sometimes impossible. Not even impossible, impossible. Right, right. So it is not going to be like that. It is not going to be like that. So what happens over here? So this was the plane mirror, and consider this as a normal. Consider this pen as a normal. What if I'm going to make this surface as curved? Oh, the position of the normal is going to be changed. Look at this. This was the plane mirror and that was your normal. And if I'm going to make it curved, the normal is also going to be shifted a bit. What will happen? The normal at this point will be lying over here. Now, angle of incidence, angle of reflection, both are equal to each other. So when it come across with the laws of reflection, angle I will always be equal to angle R, be it smooth surface, irregular surface, curved surface, it is applicable everywhere. It is applicable everywhere. I hope you got this. I hope you get this. Don't ever get confused if anyone is going to ask like where it is going to be applicable. It is going to applicable every single point, every surface, wherever the reflection is going to occur, this law is applicable. Moving ahead, formation of image. Formation of image through the plane mirror. Let me give you an idea. How many rays are actually required to form an image? How many rays are actually required to form an image? So I would say that minimum, I'm talking about minimum 2 rays are required. Minimum 2 rays are required for the formation of images, and you would be able to see your image. So over here, if I'm going to draw, let me draw a plane mirror for you. So that's your plane mirror, and I'm going to place an object over here. So this is my point object. I'm going to place over here. How the image is going to be formed? Nitya, Vedansh, very good dear. Very good. You know about that. So the minimum 2 rays are required. So how image is going to perform? First of all, I need to make this as a plane mirror. Sir, you already mentioned that this is a plane mirror. I would say this is not a plane mirror, this is glass. How to convert this into plane mirror? I need to mention one of the side as polished surface. Now this is a plane mirror. Got it? Now this is a plane mirror. Now I need minimum 2 rays. So what I'm supposed to do, I'm going to pass 2 different rays over here. According to the rule, what it says? According to the rule, yes, same distance it would be, but how it is going to be formed? So after after striking on the surface, it is going to come back. It is going to come back. Sir, but still they are not going to meet each other. How the image is going to form? See, in the plane mirror, the light ray actually, the reflected ray does not actually meet. They appear to meet. They appear to meet. Got it, Nikhil? Happy? They will appear to meet. How? How? So we need to emerge it back like that. What we have to do? We need to emerge it back. And where this appeared, where this appeared one, this point, that will be your image. This is how you can form your images. This is how it seems. This is how it seems. Same size, same distance. That is one of the property that we are going to discuss. But minimum 2 rays were required. And even over here, even at this place, if I'm going to draw normal, if I'm going to draw normal over here, you would be able to see angle I and angle R will be equal to each other, of course. Although it's a plane mirror case. Done? Done? But, sir, that was the point object. That was very easy. What will happen if we are having an extended object? Extended object means like you are standing in front of the plane mirror, which is having a certain height. How this is going to be? Let me tell you. So consider plane mirror. One of the side should be polished. Okay, done. Now consider this here as a object. What should I name this object? What should I name this object? Anant asking anyone is free. I am free. So this is Anant. This is Anant. Fine. So Anant is standing in front of the plane mirror and I am going to draw an image of Anant right now. Fine. So let's draw the reflected ray. How it is going to be? Like one of the light ray is going over here and after striking on the surface, it is going back. Similarly, over here, maybe some light rays would be passing exactly, straight away like that from the top and bottom. Like this. Fine. Now what I have to do, because they will appear to meet. So I'm going to extend it back. I'm going to extend it back at this point. Similarly, for this point. Now, what I can see over here, I can see the image is formed at this place. So this is Anant. This is image of Anant. Done. This is how you can form the images. Over here, although this light ray will be going like that and coming like that. Done. So point image, extended image, how you would be able to draw the formation of images. This is how it look like. Talking about image. So we are having two different kinds of images. That is, one is real, second is virtual. So what is the difference between real and virtual? Sometimes what happens when I'm discussing with the student, and why I'm taking those examples, because the kind of misperception or the misconception those students were having, I'm sharing with you so that you would not having that kind of misconcept. You are not going to carry any misconcept. So when I asked about with a student what is the real image, he was saying, sir, real image, what I am going to see myself in the plane mirror, because I am the real person. Imagine the kind of answer that student gave me at that time. Exactly what happens when the reflected ray is actually going to meet. So what I have to write, when someone asks you what is a real image, so I would be say, when the light rays are actually going to meet, or when the reflected rays are actually going to meet, when the rays actually meet, then this is going to form a real image. Then this is going to form a real image. Got it? Got it? Whereas talking about virtual image, it says when when rays appear to meet, rays appear to meet, exactly like we did in the plane mirror in the previous cases. In the previous cases where we have drawn the point object image and the extended object image, the light rays were, after striking on the plane mirror, they were going somewhere else, but they were appeared to meet. That is the thing. That is the thing. Can be obtained on screen. Thank you, Nikhil. Wonderful answer. Good, good, good. Very good. Very good. So real image also giving you another aspect. If the image is real, it is also going to be inverted. It is also going to be inverted. So if object is like that, image will be upside down. Inverted means upside down. So if the object is like that, image will be upside down. Whereas virtual will be giving you erect image. That means if object is like that, image will be also like that. Upright up. The upside will be up only. There will be no change like that. So this is the difference. And one more thing, where you would be able to find these examples. Let's do a very simple activity. Just turn on the torch and you would be able to see a spot on the wall, a round spot on the wall. Correct? Correct? Round spot on the wall, because you have already a screen. You must have watched Durandar in the theater, right? Or were people not allowed? Yeah. Or any movie. So you are having a theater. That screen is given and the projector is actually projecting some light, and you can see the image which is going on the particular screen where you have already went to see movie. So that particular thing, that is called real image. Image obtained on screen. Image obtained on screen. Projector. One of the example. Virtual cannot obtain on screen, cannot be obtained on screen. Obtained on screen. Example plane mirror. Yes, example plane mirror. Wonderful. Wonderful. I don't have torch right now. God bless you. I know you do not have even electricity at your home. You guys are crazy. Fine. Good. Now talking about the properties of image by the plane mirror. So what properties we can see over here, that we are going to discuss, what properties we actually observe. So the very first property, that is, the image of real object is always virtual. Such an image cannot be taken on screen. Yes, if you are standing in front of the plane mirror, you would be able to see the image, and we are not required any screen, and that is virtual. Point number one. Point number one. Point number two, the image formed in the plane mirror is always erect. Upside of the image is upside of the object. Yes, this is what we have observed. The size of the image in the plane mirror is always the same as the size of the object. See, exactly like that. So the size will remain equal to each other. The image formed in the plane mirror is as far behind the plane mirror. So the distance between the plane mirror and object will be equal to the distance between image and plane mirror. Image and plane mirror. Again, exactly like that. The distance, this d distance, will be equal to each other. The distance between plane mirror and object, plane mirror and image, that will be equal to each other. That is point number 4. The image formed in the plane mirror is laterally inverted. So that is one of the point that you need to remember. Laterally inverted. Lateral inversion, which means if you are going to take your left hand up, the image which is going to be up here will show you as a right hand up. That is one of the property that we see generally when the image is going to be formed in front of the plane mirror. Fine. Yeah. Moving ahead, types of reflection. Yes, so there are two types of reflection. There are two types of reflection. One is regular reflection, another one is irregular reflection. We have already taken that example about through the laws of reflection. So according to the definition, so reflection, that is the definition that you need to remember first of all. That is reflection of light, that is the bouncing back of light, that is called reflection. I will be directly coming towards this diagram where you can see when the parallel rays of light, what kind of light? I'm coming towards that. Vedansh, wait. I'm coming to that. Don't worry. For the regular reflection, if the parallel rays of light are incidenting on the plane mirror or the reflecting surface which is smooth, and if the light rays are going back parallelly, then it will be a regular reflection. Whereas in this case, you would be able to see irregular reflection, or you can even call it as diffused reflection. Diffused reflection. That is the only difference that you can see in the regular reflection and diffused reflection. In this, you would be able to see your image perfectly all right. In this case, you won't be able to see your image perfectly all right. That appears to meet, Nikhil, that appears to meet. That is the property of the plane mirror. This is what we studied in the last 15-20 minutes. You need to go back, you need to see it, because we had already done the formation of images. Because of the nature of the image that is virtual, which says the reflected ray, they will appear to meet at the back. That is the property. That is the property. Correct? Now the very first question, everyone, pay attention. The toughest question of the era. Find the angle of reflection if the angle of incidence is 30 degree. Find the angle of reflection. You need to find angle R if angle I is 30 degree. Yes, what will be the answer? Tell me. Tell me. Let me see how many laddus are there in the class. Okay. 30 degree. 30 degree. Okay. So only one laddu is intelligent over here. I can see only one. 60 degree. God bless you. So it says angle of incidence, when it is clearly stating that the angle I is equal to 30 degree, according to the rule, angle I will be equals to angle R, which will be nothing but 30 degree. So the one who is saying 60 degree, you need to put more attention. Was that Asta 30 degree or 300? Ananya is already living in darkness, so she went on that particular thing, that is torch. Okay. Next question is, if the ray of light incident on the mirror at 60 degree, find the angle of reflection. Or this question would rather, let me just correct it. If the ray of light is making 60 degree with the plane mirror, find the angle of reflection. It's okay, my laddu. Gupta ji, if the ray of light incident on the plane mirror, if the ray of light is making 60 degree with the plane mirror, what will be the angle of reflection? What will be the angle of reflection? In this question, I'm telling you, most of the students are actually committing mistake. Maybe they are not going to make mistake over here, but generally they do. Generally they do. And yes, Vedansh did the same thing. Nikhil did the same thing. I'm telling you again what was the question. Please have a look. According to this, they say that the incident ray is making an angle 60 degree with the plane mirror. Unfortunately, they are not mentioning the angle of incidence. I hope now you would be able to answer this. Astha? No. 120? Paap lagega re bachcha. 120 is not the right answer. 120 is not the right answer, not even 60 degree. The reason is the question was the incident ray is making an angle 60 degree with the plane mirror. I'm mentioning again and again. Incident ray is making an angle 60 degree with the plane mirror. But angle of incidence is the angle between incident ray and plane mirror, which was 30 degree. And I do not need to calculate anything further. So which means angle I, if angle I is 30 degree, then that will be equals to angle R. So please read the question very carefully, then only you would be able to solve that correctly. Please, yes, yes, yes. 90 minus 60 is 30. First time I got to know. Yes, this is just like blessing of God. 90 minus 60 is 30. See, 90 minus 60 is 80. What will be the angle of reflection if ray falls normally on the mirror? I think one of the student already asked, I think Gupta ji was there, who asked the same question. What is going to be happen if the ray of light incident normally on the surface? So it's not going to be difficult for you. Let me explain. So if this is your plane mirror, it is just like you are throwing a ball towards any plane surface. It is just like that. So that's your normal. So it says if the ray of light is incidenting normally, what is going to be happen? The answer is quite easy. It is going to reflect back along the same path. But what is the angle of incidence over here? So let me tell you, this is zero angle because this is making no angle between incident ray and normal. This is if the ray of light is going like that. This is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So this is making angle I, this is making angle I as 90 degree, and we can see the light is actually bouncing back along the same path, which means angle I and angle R will be equal to each other. They are forming 90 degree. They're forming 90 degree. Not 0. Thank you. Yes, this is what I wanted to check. Just tell me one thing. Just tell me only and only one thing. How can you trust someone, even the people like me? So consider this is your incident ray. That's your normal. Just tell me what will be the angle of incidence over here. Just tell me what will be the angle of incidence over here. What will be the angle between incident ray and normal right now? Right now. Look at this. Look at this. This is 90 degree. Now the question is, everything lies within the language. Everything lies within the language. The question can be asked in two different ways. Question can be asked in two different ways. First question, what will be the angle of reflection when the light falls normally on the plane mirror? Which means angle over here is 0 degree. Angle over here is 0 degree because normal and incident ray, they are not making any angle right now. They are not making any angle. See, this question can give you or it can make you or can take you in such situation where you will be find trapped. So there are two kinds of question. One, when the light ray falls normally on the surface, it will be reflect back, that is 0 degree. 0 degree. But if the ray of light is making 90 degree with the plane mirror, it will be passing straight away like that. That is 90 degree. Done, done, done. Yes, yes. So we need to understand what kind of question being asked. What will be the angle of reflection if ray falls normally on the mirror? So if the ray is falling normally on the mirror, it will be reflecting back, making 0 degree. Making 0 degree with the normal. So angle I will be equal to angle R, that is 0, 0, 0 degree. This is 90 degree with the normal. Got it? Moving ahead. How many minimum and maximum rays are required to form an image? Yes, we already discussed about minimum. And what is the maximum amount of rays that is required for the formation of images? Yes, tell me. Yes, champs. Minimum and maximum. So I required minimum number of rays and maximum number of rays. How many rays are required? Minimum two, Yuvraj, very good, very good. Two rays are required. Two rays are required. Perfect, perfect. But what about the maximum number of rays that we can use for the formation of images? Very good, amazing. We can use infinite number of images because any object releasing any source of light releasing infinite number of light rays, and the maximum amount of light rays that is required for the formation of image, that is infinite. Very good, very good. Love you, my laddus. Very good answer. The number of images. Now, this seems complicated, which means when the two plane mirrors are placing along with each other by forming some angle. See, there is one category. There is one category. You went to a salon. You went to a salon. You are sitting on the chair, and the barber is helping you out to make you look good again. And you can see there is a mirror in front of you. There is a mirror on your backside. You can see that too many images, too many images. So the two plane mirrors are placed parallel to each other. I'm talking about when the plane mirrors are kept at some angle, and the object is placed in between them. What is going to be happen? In that case, we require this formula. N is equals to 360 degree by theta minus 1. Depending on if the value of n is coming out as even, we are going to use this. But if n is equals to odd, the formula that we are going to consider, that is 360 by theta. We are not going to subtract. For example, if theta is equals to 90 degree, if two plane mirrors are placed perpendicular to each other, and the object is placed in between, what is going to be happen? The value of n is coming out as 360 degree by 90 degree, which is coming out as 4. Sir, 4 is even. So what I supposed to do? I need to subtract 1. So 4 minus 1, the number of images are coming out as 3. So this is how you can solve. There is one more phenomena that is called multiple reflection. Multiple reflection, it happens where you are having such kind of structure where the light rays are actually going to travel again and again, where the light actually passing through it, and you can see the multiple reflections can be done like that. You must have seen few instruments where you have played with some instrument where this multiple reflection been used. And what is that? Like in that case, if this kind of pattern you would be able to see, you can see such kind of pattern would be obtained. Have you seen that kaleidoscope where some small pieces of glass bangle is going to place, and when you see in front of the light, you would be able to see such kind of pattern. Because of the multiple reflections. But when we talk about periscope is something which is used in submarines. This is used in submarines. How it is being formed? So you take a box. We need to place a plane mirror over here and one plane mirror over here, and this part will be removed. So that we can see the reflection. So let's consider you are using this device and object is over here. The enemy object is over here. So the light ray will be striking over here, will be incidenting over here, and you can see the image. Of that. So that is being used, the phenomena of multiple reflection, and periscope is going to be one of the finest instrument that is being used, is still being used. So what we discussed so far. So in this lecture, how it uses many mirror at different angles. If you are talking about a kaleidoscope, yes. Periscope, we require 2. Depending on the shape, most of the cases 2 mirrors are required. Yes. In case if you are having any doubt right now, you can even write down in the chat box. write down in the comment box. Later on, if you are watching this recording, you can even go to the PW English channel or Instagram handle, where you can put your doubt in the message box and we are there to help you out. In today's class, we discussed about object, image, reflection of light, reflection of light. We discussed about plane mirror. Plane mirror we discussed, na? Yeah, plane mirror. Reflection, that is through point object, extended object. This is what we already discussed. And later on we discussed about multiple reflection, laws of reflection, laws of reflection, laws of reflection, multiple reflection, multiple reflection, and etc, etc, etc. This is what we discussed. I can see in the comment box you are able to answer most of the things, which means you can relate this topic. You can relate this topic from class 8th, or maybe you have studied, maybe you have come across with this kind of topic, and the reason is because you have come across with this bridge course will be definitely helping you out in that. And what you have to do, you have to come along. You are having your timetable, just be there at 4 o'clock or maybe 6 o'clock, that the classes would be provided to you. So be there. Thank you so much. Thank you, Vedansh, for giving your precious love also. Thank you so much. And signing off. Thank you. Thank you once again. Bye-bye. Good night. Take care. Love you all.